everybody. This is 5.4, Comparing and Graphing Ratios, Part 2. Okay, how do I use a unit rate, or how do I use unit rates to compare prices? Okay, which bag of dog food is the better buy? We have a 20-pound bag and we have a 30-pound bag. And here's what we got. We have 20 pounds for $17.20 and 30 pounds for $25.20. Now, I don't know if we went over last time. Money always goes in the numerator. It doesn't have to, but we typically put it in the numerator. And so it's a certain amount of money per pound. And pounds are libras, which we do LBS, which means pounds. It's a Latin thing. Don't worry about it. But whenever you see LBS, that means pounds. Okay, the 20-pound bag is $17.20 for 20 pounds. And the 30-pound bag is $25.20 for 30 pounds. Right now, the pounds are not the same. So although the price is cheaper for the 20-pound bag, it should be because it's less dog food. If we're comparing these, what we want is to have the same denominator. We want the better buy. We want to pay less per pound. So let's find out how much this is per pound. How do you do that? You find the unit rate. By dividing 20 by 20, you get 1 pound, right? So now what you need to do is with the numerator is take the $17.20 and you're going to divide that by 20. On your homework, you're going to have a calculator, so it'll be pretty straightforward. You're just going to take your calculator, type in $17.20, and you're going to divide that by 20, and I got 0 and 86 hundredths, which is the same as 86 cents per pound. On the 30-pound bag, we do the same thing. We divide the 30 by 30, and that gives us 1 pound, but then we must divide also the $25.20 by 30, and so I'm going to do that in my calculator, and I get 84 cents per pound. Now, when we're asked to find the better buy, we want to pay less, not more. So although 86 cents per pound is a higher number than 84 cents per pound, we want to pay less. So the 30-pound bag is the better buy. Remember, we always put money in on the top or in the numerator. To compare prices, we need the price for the same pounds, right? Same weight. One simple way to do this is to find the cost of 1 pound of each dog food. This is called the unit rate. All right, pretty good. We're doing really well. Let's move on to the last example where we're actually going to graph these. Let me scroll down here and let's do this. How do I use ratio tables and graphs to compare ratios? Okay, hot air balloon rises 9 meters every 3 seconds. Let's stop right there. Here's the balloon. Time, height, 9 meters in 3 seconds. If we double the amount of time, multiply by 2, what do we have to multiply 9 by? 2. So this is a ratio table, just up and down, right? It's still the same thing. Whatever we multiply the time by, we multiply the height by the same thing. So now if I want to go from 6 seconds to 9 seconds, there's no good way to do it. But can we go from 3 seconds to 9 seconds? Sure. We can do 3 times 3 is 9. That's supposed to be a 3. Sorry. And then we would multiply 9 times 3, and you get 27. And you could do the same thing. I think you all get it. 3 times 4 is 12, so 9 times 4 is 36. And we'll just keep on going. A blimp rises 7 meters every 2 seconds. So that's a different rate, right? And so we have the blimp over here. Same thing, time and height. 2 times 2 is 4. 7 times 2 is 14. 2 times 3 is 6. 7 times 3 is 21. I don't know. 4 times 2 is 8. 14 times 2 is 28. Now, notice how they've set this up. They have time on the x-axis. So this is time going by. 0 seconds, 1, 2, 3. Time is going by, right? Ticking by. And as it ticks by, the height of the balloon and the blimp are increasing, and that's why you have these two lines. So let's take a look at like one of the points. This is in 2 seconds. This is a little less than 8 meters in rise. Well, which one is a little less than 8 at 2 seconds? That's the blimp, isn't it? So that's 2, 7. And then 4, 14. So let's see, 4, 14. Yep, that's about right. Then the next one is 6:21, 6 seconds. It's at 21. That's a little more than 20. Good. And then the last one is 8 seconds, and that's at 28. So 8, 28. So that blue line must be the blimp. And I don't have enough space here, so I'm going to right outside the lines. Such a lawbreaker. Is this red? Yeah, it is red. Okay. And the next one, we have this one going. That point right there's 3, a little more than 8. Well, that must be the balloon because that's 3, 9. There we go. Next one is at 6, and then between 16 and 20. That's 6 and 18, so that looks correct. Next one is 9 and a little less than 28. Yep, 9:27, that's correct. And then this point right here is at 12 seconds up to 36 meters for height. So 12 and 36. So that must be the balloon. Even less space. I did better that time. Okay, now you can see which one's higher. As the time's ticking by, look, the blimp is getting a little bit higher than the balloon as the time goes by, and eventually that will be a big difference. So the blimp rises. I know it's in red, it's probably confusing, but it's the blimp. The blimp rises faster because it is a height of, well, where do we have the same number of seconds or the same height? I'm trying to look for anything that's the same here. Well, we do have 6 seconds here and 6 seconds here. So if you go to the 6 seconds mark, you can see that the balloon is only at 18 meters high, while the blimp's at 21. So because the blimp is at a height of 21 meters after 6 seconds, while the balloon is only at a height of 18 meters after 6 seconds. So once again, the time is the same. That's how we were able to compare which one was rising faster. All right, everybody, that ends this lesson. Please email me if you have any questions on the homework.